Piecewise functions. Just like its name, a piecewise function is a function that is made up of pieces. We can create functions that behave differently based on the input x value. Piecewise functions let us do anything we want. To completely understand how to make the graph of piecewise functions, we are going to start explaining greater than or less than signs. When a is greater than b, it will be written as. On the other hand, when d is less than c, it will be written as. We can use the analogy of the crocodile's mouth, it's the greater one. When we need to indicate the values for x, we use the symbols to indicate where it begins and where it ends. Here we have x is greater than -2 and less than 3. In this example, -2 and 3 are in values of x, but sometimes they can be included if the symbols are greater than or equal or less than or equal. And we can indicate this by drawing a line below the greater than or less than signs. A short reminder, types of functions. There are many different types of functions such as linear functions, quadratic functions, root functions, cubic functions, absolute value functions, and rational functions. We can find a lot of movements in the graphs. First, the vertical movement. If the function has a plus sign outside the parentheses, the graph will go upwards. If it is a minus sign, it will go downwards. Then the horizontal movement. If the function has a plus sign after x inside the parentheses, the graph will move to the left. If it is a minus sign, then it will move to the right. Reflection movement. If before the whole function there is a minus sign, the equation will reflect in relation to the x-axis. If the minus sign is inside the parentheses before x, it will reflect in relation to the y-axis. Now that we know the basis of graphs and functions, let's start graphing piecewise functions. First, we must draw a Cartesian plane, then analyze the type of equations that form the function, then establish the domain of each equations, and finally, draw the graph and establish the domain and range of the whole function. For example, in this example, the first is a quadratic equation, x squared minus 2, when x is smaller than -1, so its domain will be -infinity to -1 not included. The second equation is a cubic equation, minus x cubic, when x is greater than -1 and less or equal to 1, so its domain will be -1 not included to 1 included. Finally, the third one is the linear equation, minus x plus 2, when x is greater than 1, so its domain will be 1 not included to positive infinity. Now let's make the graph. In the first equation, -1 is included, so it is represented by an empty circle. The other is infinity, so by rule, it must be represented by an arrow at the end of the line. In the second equation, -1 isn't included either, so it has to be an empty circle. 1 is included, so it has to be represented by a full circle. In the third equation, 1 isn't included, so it is an empty circle. And the infinity is represented by the arrow at the end. Ultimately, we must calculate the range and the domain. The range will be all the real numbers because the graph touches each of the values of y at some point. The domain will be from -infinity to -1 excluded, union -1 to positive infinity. -1 is excluded because the graph at -1 in the x-axis has an empty circle. And that is all for piecewise functions. Thanks for watching.